Hello. In this lesson, we're going to take a look at the new Geometry Solver. This particular tool allows you to take geometry operations and use the last frame as reference to what to do as you move forward in time. Because of Houdini's procedural nature, things often update. As you move through time, the operation would update through time, and the solver allows you to simulate a sort of repetitive action. The best way to really describe this is to see it. Let's take a look at this footprint example. Here we have a character moving through the snow. Now in this case here, we are not using the solver node available now in Houdini. In this case, we're using a ray operation to push down the snow, and we're also using an attribute transfer to take some information from the character and push it onto the snow. And as you can see, it's doing the pushing of the snow, but as the foot leaves, the surface restores itself. That's Houdini's procedural nature, which is a wonderful feature in many circumstances, but not what we want in this case. So let's take a look, go back, and I'm going to open up this network where we have the basic network that we're working with. In this case here, we have the grid coming down, the character coming down, and there's, in this case here, we attribute transferred ray, and then that gives us our look. Now over here, what we're going to do is we're going to turn on the one that comes from this solver. So these two nodes here, the attribute transfer and the ray, were actually placed inside the solver node, and that gives us a much different result. And let's go back and take a look at that from the object level. So now, as you can see, the character moves forward in time, and instead of the footprints disappearing as he moves forward, he's actually leaving a trail, and that trail exists because the geometry from the previous frame is used as a reference to do the modeling for the next frame. This is actually taking advantage of Houdini's dynamics architecture, which is built into the solver node, and it's something that adds a simulation into the modeling context. Now, how do you set this up? Let's go take a look. We'll start from scratch and build up a scene similar to this so you can see how it works. Okay, so starting from a blank screen here, what we'd like to do is start off with a grid. Okay, now we don't need this. We're going to take this grid, we're going to change it to 40 by 60, and we'll do 61 grid squares by 41 grid squares. That'll give us a nice, then we go spacebar H, that'll give us some nice detail to work with. Let's take the sphere tool and put a sphere down in the middle. We'll make that a polygonal sphere with a frequency of 4. Now, instead of putting the sphere node directly in itself, we're going to take that sphere node and we're going to extract it to create what an object merge, a sort of a copy of it. This will actually give us some freedom later on in terms of plugging something differently in other than the sphere into the system we're creating. We're then going to take those two things and combine them into a new network, which is basically the grid and the object merge sphere coming in and being merged. Now we're going to delete the merge for now, and we'll combine these in a different way. Now we're going to start by, we're going to set up the attributes that we're eventually going to transfer from one to the other. They're actually going to be the same attribute. We're going to call it dirt map. And it's going to be a point attribute, and we're going to feed that with a value of 0 onto the grid. Now we're going to copy and paste that and feed that into the sphere. And this time it's exactly the same name, but the value is going to be set to 1. Now, we can then use a tool called attribute. I'm going to pick that here, attribute transfer. And that one you can plug this one into here, this one into here, and you've transferred the attribute. And if you middle click on this, you'll see dirt map is an attribute that exists on there. Now to visualize what we've done so far, let's right click on here and put down a group geometry node. This will allow us to isolate out those points that are part of the dirt map sort of family. So dirt map is greater than 0.9. Okay, and you'll see that we've got a sort of a zone there of which that works. Okay. Now, currently we've got it going, these were all points. We actually, if we wanted to, probably better go points here, points there, and just pick dirt map there to make sure that that's going through properly. And then we can go to the grid, and there we go. And we've got, that can be set up on points as well. Now, you can't see it quite as much, but we do have that working properly there. Now, we're going to then take a color node and based on the group 1 attributes, we're going to just put some color on there. So all of this area here is all being transferred because of the position of the sphere. If we go back to the attribute transferred node, we can look at the conditions, and we can actually reduce that down to, let's say, 1, or actually 0.25. We might go a little tighter for later on when we do the footprints. Now, so this gives us our network, which has our attribute creates, our attribute transfer, and we're transferring that down. If we go back to the object level, and we take a look at, let's make the grid object unselectable and then grab the sphere. So as we move the sphere around, you'll see that it's updating where the attribute transfer is occurring. We can also press K to set a keyframe. Let's change the frame range to 120. Move our second frame to 120 and set a keyframe. And what we're going to show you is that not only does this update when you move it, but it'll also update it if there's any animation. So the procedural nature of Houdini sort of holds true during an animation. So if we press play, you'll see that the attribute transfer is working on a frame-by-frame basis, and we're transferring the attributes. Now the thing is that what we want to do is we don't want to just transfer it sort of and then have it forget what happened. We want to leave a trail of all the places where this attribute transfer has occurred. And we're going to do that by going back into the grid object. And now, beside this attribute transfer, we're going to put down one of these new solver nodes, the geometry solver. We're going to click down. We're going to feed the grid path into the first input, and the attribute create from the object merge into the second one. We're then going to copy and paste the group and the color, and that will give us our new path. Now, this isn't going to work yet because we forgot one node, the attribute transfer. What do we do with that? Well, it doesn't sit outside of the solver. It actually gets copied. I use Command C, Command V to paste that in. Now, if we put input 1 into here and input 2 into here, which we'll put input 2 into there, we'd get pretty much what we had before. But if we put previous frame into input 1, we're going to get a whole different situation. And we're going to take that up to this level here. And we'll go back to this frame here and press play. And what you'll see is that now we are actually sort of smearing the surface with the attribute transfer. The dirt map is now going on the surface on a frame-by-frame basis. So this is quite powerful and is a great tool for that. Now, we can do other operations too. If we were to put down, let's go back to this sort of side of things where things update on a frame-by-frame basis. And after attribute transfer, we're going to put the ray. And ray will actually allow us to push the surface, or actually it's pulling on the surface right now, but we're going to push the surface with a sphere. And if we were to go through this path, you'll see it's pushing the surface on a regular basis. So that's good, but we want it to again leave a trail for that. So we're going to take the ray, we're going to copy it, put it into the solver node, feed input 2 into there, and make that the display. And when we jump way back up here, we can set the display flag on color. And now you'll see that not only are we sort of smearing the surface with the dirt map, we are also cutting a groove into it using the ray. And this, of course, is the basis for what we're going to do with the footprint. This gives us our footprint capability. Now, couple things at this point. One is the surface we're working with, because it's a grid, you're going to get this sort of weird, sort of jaggy trough here. So we're going to actually make a quick modification to the way the grid is configured right now. So instead of having 61 by 41, we're going to go 2 by 2 grid. We're then going to put down a triangulate 2D. This node will allow us to create a different kind of breakdown of the surface. And now as we go through there, you'll see that it's, well, actually we should put the display on the final color node. You'll see that the trough is a little bit more organic, and it will actually, if you put a subdivide on this afterwards, actually looks quite nice, and will certainly look like an object pushing its way through the snow. So there we've got the basic functioning parts of our snow tool ready to go. Now, to bring the footprint in, let's import geometry, and we're going to bring in the snow walk that we have. And it's not really oriented very well, so we're going to go down, put down a transform, and we'll just rotate that around, push that down so it's actually in the surface. And now when we go back into this object, which if we want to, we can rename that snow, because that's the actual snow surface. We can take the object merge at the top of the path here, and instead of pointing that towards the sphere, let's point that towards the snow walk X form. Now you'll see that we're pushing down the surface here instead of over here. Let's go back to the object level. Let's turn the sphere off and press play. And what you see is that we've actually got the sort of footprints being pushed into the snow, just like we did earlier on in the lesson when we introduced the concept. Now, in that other example, I also pushed and pulled the surface. I added a mountain onto the surface, made it a little more organic. But in essence, the basic functionality of what we're talking about is right here. Now let's just get the select tool, zoom in, and we can sort of see that sort of in the surface there. Now, oops, certainly didn't want to do that. If we go down to the snow, if we want to, like I said, we could add a subdivide and maybe add a depth of 2. And you see how we get a nice sort of look there. This will be a lot slower, but it has sort of a nice snowy look to it, which you could work with. So now you've had a chance to see what the solver node does, how it takes a particular operation which would normally update on a frame-by-frame basis and allows you to create a trail or a memory of that operation over time through the simulation method. Now, just to show you a little bit, one other thing about the solver node is as we go into the solver node, you're actually going through a number of different levels, of which some of them are actually in dynamics and so on and so forth. But this tool is designed so that you go into it and go right to where you need. If you dive out, you're out of it. So you don't need to worry about those other levels that are in there. They're just there to make sure all the parts are functioning properly, and you get a simulation out of this example. So hope you enjoyed this lesson.